Hi students, in this video we're going to learn how to calculate the length and the midpoint of a line segment. So our learning goals for this video: after watching this video you should be able to calculate the length of a line segment and also the midpoint of a line segment. The key thing to recall is a line segment is a line between two fixed points. So usually when we draw lines, especially when it comes to graphing lines, they go on and on forever in both directions. A line segment is just a little section of that line that would be in between 2 points. So a line goes on and on forever in two directions. A line segment is just a fixed part of that line that goes between 2 points. Alright, so what we're going to do is find the length of this line segment between 3, 1 and 9, 5. I'm going to add in some lines, and then after I've added in the lines, I want you to have a think about if you can find the length of this line without following the rest of this video. Alright, I've added in some lines there just along our Cartesian plane that have now turned this line segment into a right angled triangle. Once we see a right angled triangle, we should now start thinking maybe we can use some trigonometry here, and in particular, if we're finding this distance, let's call it d, we could use Pythagoras' theorem here. So we need to find the length of this line, which we can calculate using 9 minus 3, which equals 6. In the same way, this vertical line, 5 minus 1, it's 4 high. Now using those values, we can find our value for d really easily. Now the key thing is here, students, that this calculation is the same as x2 minus x1, or it's our change in x, right? The change in our x coordinate. And in the same way, in the y direction, that's the same as y2 minus y1, or our delta y, the change in our y direction. And so that's the notation we're going to use in our length formula for a line segment. So the length of a line segment is given by d is the square root of our change in x squared plus our change in y squared, or d is the square root of x2 minus x1 squared, right, this distance here, plus y2 minus y1 squared. And again, students, that's just Pythagoras, basically saying d squared equals delta x, or x2 minus x1 squared, plus delta y squared, our change in y value, y2 minus y1. And then to get d on its own, we apply that square root. That's all we're saying. So in this situation here, we've got d equals the square root of 6 squared plus 4 squared. 6 squared is 36. 4 squared is 16. 36 plus 16, square root 52. So 7 and a bit will be the length of this line segment here. Again, that's just using Pythagoras. So you might remember the distance formula or some version of it, but the idea is we're just using Pythagoras. And our sides are our change in x and change in y, or x2 minus x1 and y2 minus y1, the same sort of variables and changes we have in our gradient formula. Alright, now looking at our midpoints of a line segment, looking at our picture here, we can say, right, our midpoint should be halfway between our x coordinates. If we've got a 3 here and our 9's up here, the midpoint should be halfway in between, here at 6. And same for our y values. We've got a 1 here and a 5 up the top. The midpoint should be halfway in between at 3. And there's our midpoint, 6, 3. Really simple. Now, what we're actually doing there, students, is just finding the average of our x coordinates. So the average of 3 and 9. Right? 3 plus 9 is 12, divided by 2 is 6. That's the x value for our midpoint, the average of 3 and 9. For our y coordinate, it'll just be the average of our y values. 1 plus 5 is 6, divided by 2 is 3. The average of our y values gives us the y coordinate of our midpoint. So the midpoint of a line segment is given by, for the x coordinate, the average of your x values. For your y value of your midpoint, it's the average of your y values. And that average should get you the middle every single time. Alright, so after watching this video, you should be able to calculate the length of a line segment and also determine the midpoint of a line segment.